Hi everybody, today I'd like to talk to you about the types of variables and maybe apply them to some graphs. So I have some data here. This is Indianapolis winners, some Indianapolis winners, and we just wanted to see what it looked like when we recorded a bunch of data with a bunch of variables. And you can tell we have quite a few variables and some variable types here that we see. Year is a type, a name of the winner is a type, the pole position, the average speed, those are all variable types. And so somebody can ask, example, what year, and because the answers are all different, that data for what year goes into the variable called year. And so we have essentially two types of variables, categorical and quantitative. And so our first job is to identify what is a categorical and what is quantitative. So we'll see that in this case we have categorical winner and we have a categorical pole position. Both of these are winner names, but you could have categorical, for example, where people have just answered yes or no. Or you could have categorical, like what favorite flavor ice cream do you like? So these are all essentially, my students like to call it answer with words. And so let's move on. There's a couple of quantitative. So it's either categorical or quantitative. Okay. So again, categorical variables, for example, names, yes or no. They're usually non-numerical in nature. So let's look at the quantitative types. There's actually two types of quantitative data now that you've identified quantitative data. And that is, did you acquire this data by counting it or did you acquire it by measuring it? And neither of those are really the stats terms for them. So if we talk about counted, that's going to be called discrete. And if we talk about measured data, that's going to be called continuous. So the words discrete and continuous are very important to us, so that tells us what kind of variable it is. So let's take a look at the kinds of quantitative data that we have. Which one of these do we think are discrete and which one of these are continuous? So which one of them is obtained by counting and which one of them is obtained by measuring. Okay, so let's take a look at these guys. So we count what year it is, and we count what pole position you have. But when it comes to average speed, we measure the average speed. And notice one big tell about whether something is measured or not, continuous, is that if you can get more and more exact, so notice the decimal point, you could actually, speed is such that you could take this to many, many decimal points. And so we know that that's going to be continuous. And again, we have speed here for average pole. So we have discrete and continuous. Let me give you an example of graphing either discrete or continuous data. So I'm going to start with the first graph. This graph is what we call a dot plot. It's going to represent the number of states visited in 2015. So notice I have a number line, and a person's going to come up and they're going to put their dot for how many states they visited in 2015. And I always like to label every axis that I have. So I labeled it states, and a person came up and put a dot. Actually, it's not a dot. I know it's an X. Dots are actually hard to see. So in my class, we like to use X's. So a person answered 4. They visited 4 states in 2015. And now the rest of the class will come and put their dot up. Notice the X's are all about the same size, because we don't want to lie with our eyes. We don't want to violate the area principle. But now that we see the dot plot formed, we can take note of its shape, center, spread, any outliers, and that will be for a different discussion. But notice that organized data is really nice to see. And so how did we acquire states visited? So if number of states visited is our variable, how did we figure out the number of states? And we did so by counting them. So this data is quantitative discrete data, discrete data, because the states are counted. So what if we didn't have discrete data? What if our data was continuous instead? Then a dot plot would probably be too hard to use because of the decimal nature of something that's measured instead. So in this case, I'm going to create a different kind of graph. Notice my graph is going to be about milligrams of solution, and on the left-hand side, I have frequency. Frequency just means how many. And so notice now I have these bars, and so those bars are going to help me graph something that's continuous or measured. Because, for example, if I had 410.05 or 329, I don't know if I'm talking about dosages, but I can put them into the section and that'll build the bar. And so this is not a dot plot that you're looking at. This is what we call a histogram. So a histogram is really good for continuous data. And there are other graphs as well. So, and when we read this histogram, we can say something like, look at this tallest bar. 7 times there was a dosage of a solution somewhere between 400 and up to, but not including 450 milligrams. So that's what's nice about using histogram, is it contains all of that measured data within that one bar. All right, I hope this helps. Stay well.